Hello? Okay. Hi, everyone. So my name is Breznen. I'm working as a technical specialist for our new acquisition, which is HashiCorp and the whole portfolio. And today I'm going to present one of our leading solutions, which is HashiCorp Vault, mainly focused on the security lifecycle management and managing of secrets. So I will start with the problem definition and why do we even have Vault. So the problem is called secret sprawl, and it means that we have a lot of secrets in our organization that are unmanaged and they are not managed securely. Yeah. So typically we see that some of them are stored in Git secrets, some of them are stored in environment files. In the worst case, but it is also happening. They are hard coded in Docker files. They are hard coded in some source codes and all configuration files. Very often we see developers are lazy and they just put all the secrets in there as hard coded ones. It leads to several issues. Yeah, of course, it is very hard to rotate those secrets because whenever they are hard coded, you need to change the whole source code, redeploy the application again, and the process is really sophisticated and it takes a lot of time. It often leads to shared secrets and outdated secrets. Yeah, of course, whenever you don't want to rotate them, you create big secrets with a whole huge access permissions to all of the applications. You put it into the application and you just leave it there forever. Yeah, it is really unsecure. It leads to audit issues. So whenever an audit comes to the organization, they often have problems with those hard-coded secrets. You are non-compliant with rotation policies, and yeah, the biggest issue, of course, is the leakage of secrets. We know that in our organizations nowadays, more than 33% of hacking attacks are not some sophisticated SQL injections or any other attacks, but just developers pushing those secrets to some version control system like GitHub, GitLab, and yeah, the issues are real and the attacks are really happening. Just to show you an example that it really happens, I've created a prompt that searches through public GitHub repositories, and it searches for OpenAI API keys. Yeah? So whenever you run this prompt on the GitHub search command, you find 87,000 of leaked OpenAI API keys. Yeah? And this is just OpenAI API keys. Whenever you would go for GitHub access tokens, whenever you would go for any other tokens, you find much more of those secrets leaked in version control systems. This is just a public GitHub, but you can imagine in some enterprise company, GitHub or any other version control systems, you will have loads and loads of these secrets which developer pushed there and don't care about how they are managed. So because of these issues, HashiCorp created a solution called HashiCorp Vault, which is one sentence, it is a tool for securing, managing, and managing access to sensitive data in your organization. It should be a centralized place of those secrets, so it should be one place in which you manage all of your secrets in the organization. It provides the whole lifecycle management of those secrets. So from the creation of the secrets, through rotation of those secrets, until the decommissioning phase, all involved, all managed. The last layer is, of course, governance and security, which is whenever someone is accessing Vault, they are really checked that they have the access rights for those secrets, and they are limited to only the secrets that they really need to use. At the bottom, we can see a simple workflow of how applications interact with Vault. So you typically have an application, pipeline, or even in some cases users. They reach Vault, they want to consume some kind of secrets. Vault will check the permissions. If they have the permissions, Vault will return the secrets to the application. Yeah. By secrets, we typically mean not only username, password, and API keys, but also some more sophisticated structures like certificates or even encryption keys. Okay, so now I'm gonna go through all the use cases that Vault actually can manage and can do. So the most basic one, static secrets. Of course, all of you probably know static secrets. These are the ones that are generated by humans. They are long-lived and they are in their organization for a long time. Yeah. They are not ideal because they are static, and whenever you create this secret, it lives forever. But of course, we know that organizations will use those secrets, and they will be still there. So Vault can manage those secrets in a very secure and major way. So of course, it will be a centralized place where you will store those secrets. They will be stored securely. They will be stored and managed by Vault. So whenever you need to rotate them, you know where they are stored, how to rotate them actually. You can not only onboard applications that talk to Vault directly, but you can also onboard some legacy applications that are not using Vault currently. Yeah, so you will typically do it by something called Vault Agent. Yeah, as you can see on the bottom, we have some specification when we specify an environment file that the application already uses. So this is the typical workflow without Vault. We have an environment file, we have an application properties file, we have some values like database host, database name, database passwords. What we can do with Vault and Vault Agent injection is actually inject values dynamically according to the value that is stored in Vault. So Vault Agent will sit on the environment file. It will watch the secrets in Vault. Whenever they change in Vault, it will inject them into the environment file of the legacy application. So this is one way of how we can interact with legacy applications and Vault. But of course, we can interact also with more modern workflows like Kubernetes. Yeah, so you can see we can leverage some workflows for Kubernetes where first we can use a Vault agent sidecar. Yeah, so whenever a pod spin ups, Vault will attach a sidecar that will mount secrets into environment variables or files whenever the pod spin ups. This is the most basic use case that Vault implemented on Kubernetes. But nowadays, the more modern way is to use Vault secrets operator, which is a typical operator on OpenShift or on Kubernetes, which you install. And then you can define a synchronization from Vault to Kubernetes secrets that are stored in etcd, or even mounting some secrets directly into the pod as a volume. Yeah, the mounting is called the CSI mount, where you, instead of storing the secrets in the typical Kubernetes secrets, you mount it directly to the pod as a volume. The other benefits are, of course, versioning of those secrets. So whenever you create a new version, you can always come back to the previous version of the secret. And of course, governance and auditing. Every operation that you do with Vault, so every API call, every write, every read, is part of an audit log. So whenever an audit comes to the organization, you can always prove that you are rotating the secrets and you are managing them in the right way. So these were static secrets, but the idea of Vault is to push the security level to the next level with something called dynamic secrets. Yeah? So dynamic secrets, in comparison to static secrets, are generated dynamically on demand by Vault. Yeah? They are not stored anywhere, but whenever an application needs the secret, it requests it from Vault. Typical workflow, as you can see on the image, we have an application that needs to connect to the database. And instead of using credentials that are stored on the application side, you will use Vault as a generator of those dynamic secrets. Yeah? So in this case, we will want to generate username, password for access to the database. How it will work, application will request those dynamic secrets from Vault. Vault on the background will talk to the database and generate a short-lived username, password credential that it will manage on his side. Yeah, so whenever it creates the credentials, it returns them to Vault, and Vault returns them to the application. Now application, of course, can use those credentials for connecting to the database, and after the time to live of those credentials is ending, or the credentials are expiring, Vault will go again to the database and revoke those credentials on the database side. And so this is the main idea of Vault and dynamic secrets, which are generated on demand. We can do natively this functionality with databases. We can do this with cloud providers and generating of access tokens to these cloud providers. We can also do this with SSH one-time passwords or generating SSH certificates, for example, for Ansible scripts to actually connect to the target devices. So we don't use any static SSH keys, but we generate those SSH keys on demand whenever we run the script. Another use case is, for example, RabbitMQ and generating username passwords. But of course, we are not limited only to those use cases. Those use cases are provided by HashiCorp as a built-in feature in Vault. But you can always create your own dynamic secrets engine to actually provide those dynamic secrets also for your custom applications or any other applications that are not specified in the list. Okay, so these were the secrets, static secrets, dynamic secrets. All of these types Vault can work with very well, but it can also use those secrets, for example, for some other workflows like agentic workflow, where we don't use hard-coded secrets on the MCP server, which is typically happening right now because organizations need to scale up AI very quickly, and they are not really using the most secure methods like generating the secrets on demand. So what they are doing is storing the secrets on the MCP server, static secrets that are reused for all the users that use the AI application. What we can do with Vault is actually leverage a dynamic workflow where we will know which user is logging to the application, and based on the user that logs into the application, Vault will generate dynamic on-demand credentials that will be used for the AI agent to log into the third-party service. So the idea is to make it more secure and make it like the end user would be logging to the third-party service himself, but he will be using the AI engine instead. So these were the secrets. What we can do also is many more, like encryption as a service. So Vault is not really just a secrets manager, but it can do a lot other features like encrypting. So typical use case, again, we have a credit card number that we need to store in a database, and instead of the application itself doing the encryption logic, we can use Vault as an encryption as a service. So we will send the credit card number to Vault. Vault will choose an encryption key, which we will be also storing in Vault. It will do the encryption itself and return the encrypted text to the application itself. So then, of course, the application can store the encrypted text in the database itself. This way, you offload all of the encryption logic to Vault. You don't need to manage the encryption libraries on the application side. You don't need to manage the encryption keys on the application side. Everything is managed securely, encrypted in Vault, and the only thing you need to do is send the text and specify which encryption key you want to use for the encryption. The other way around, same workflow, you just send the ciphertext to Vault. Vault will return the plain text, and you can work with the plain text in whatever way you need on the application side. Again, no need for choosing encryption keys, no need for storing them. Also, not only encryption as we all know it, like the typical way where you run your plain text through an encryption algorithm that is using some encryption key, you can also use a data transformation engine. By data transformation, we mean, in the first place, tokenization. So whenever you need to tokenize your text, you don't want to use those encryption algorithms as we know them. You can use a tokenization engine that will tokenize the text. You can use something called format preserving encryption, which is encryption approved by NIST. It is based on an AS cipher, and it leverages the existing alphabet of the plain text, also in the outputted encrypted text. Yeah, so typically, whenever you need to store a credit card number, you need to encrypt it, but you also want the encrypted text to look like your plain text. You can leverage this engine, it will encrypt it, and it will also look like a typical credit card number. It is very useful, for example, when you need to store the data in some other database, you want to encrypt them, but you also don't want to change the format of the data and don't want to change the format type in the database rows. The last data transformation action that we can perform on Vault side is data masking. So again, if you need to mask some part of data, you will just define a regular expression on the Vault side. You will run these data through Vault, and Vault will mask the parts of the data that you want to cover. Okay, so this was data transformation, and one of the most popular use cases nowadays that we register in Vault is Vault acting as a certificate authority and automating the whole PKI lifecycle. Yeah. So how does it work? You typically already have some root CA in your organization. It doesn't matter if it is Microsoft CA or if it is some cloud CA or if it is just a private and public key of the certificate authority generated by OpenSSL. And in this scenario, Vault will work as an intermediate certificate authority. Yeah, so whenever you want to generate the certificate, Vault will generate it from the intermediate certificate authority private key. How does it work? Whenever you need to set this scenario up, you will just generate a CSR on the Vault side, you will sign it from the root certificate authority, and insert the signed certificate to Vault. So from now on, Vault can act as a certificate authority. Whenever you would like to, you can go to Vault, click generate, and you can generate a certificate that will be generated by this intermediate certificate authority private key. But the main idea is to automate the whole workflow. So what you can do as well is set up a virtual machine, for example, a virtual machine where you have the application running. You will also install something called Vault Agent on the virtual machine, which will be managing the certificates that are provided to the application. Vault Agent will look at the certificate whenever the expiration date is getting close to whenever the certificate is getting close to the expiration date. It will again talk to Vault and request automatically a new certificate from Vault. Yeah. Vault will check if the Vault Agent has the correct permission, and it will return the newly generated certificate to the Vault Agent. Vault Agent then can provide the certificate to the application in whichever way you want. It can be a custom script, it can be a REST API call, or it can just store the certificate on the file system. Yeah, so this way, you will automate your whole PKI infrastructure, which is like really useful. We see a lot of organizations that are still leveraging the manual certificate lifecycle management, and yeah, it causes a lot of problems. Whenever you forget to rotate the certificate, the whole production environment goes down, and there are many issues with the certificates. So when you set this up once, you don't need to care about the certificates at all through their whole life cycle. This workflow, as I'm showing now, is working for the internal certificates mainly, but in the latest release of Vault Enterprise, we can also automate the whole PKI infrastructure of public certificates. Yeah, so again, typically you will have a certificate authority. In this time, it won't be a root certificate authority that you generated on your own in your organization, but it will be some kind of public certificate authority. Yeah, so typically, Let's Encrypt, or we support any other certificate authority that can communicate through ACME protocol. In this scenario, again, you will have a Vault agent that will manage the certificate and its life cycle. So it will check whenever the certificate needs to be rotated. It will check whenever if the certificate even exists. If it doesn't exist, it will again request a new one, and it will request it from Vault, which will be acting as an ACME client. Yeah, so ACME client, typically you maybe know it also from other workflows. ACME client is, for example, a certbot or any other. And in this case, it will be Vault. Yeah, so whenever the certificate is about to expire or the certificate needs to be generated, Vault agent will talk to Vault to create and request the certificate from the public CA. Whenever the agent creates the request, Vault will forward the request to the public certificate authority. Certificate authority will perform the HTTP 01 challenge. Right now, we are supporting only HTTP 01 challenge, but in the future, there is a roadmap for also DNS challenge. Whenever you generate the certificate, it will return it to Vault, and Vault will also cache the certificate and provide it to all the destination points that we need to provide it. Yeah, so in this case, Vault will serve as an ACME client, but again, you will automate the whole certificate lifecycle of published certificates. You set it up once, and you don't need to care about it at all for the future. This is all from me. If you have any questions, I will gladly answer them.